Okay, this is going to be a really quick video where I talk about how we represent the dissolving of a salt in water using chemical equations. So if we have something like sodium chloride and it was a solid, but we want to show that it's dissolving in a liquid, then we can represent it as sodium plus and chlorine minus, and then we say both of those things are aqueous. So the way we represent the ions is with the actual charge on the ion as a superscript, aqueous after to recognize its state, and then same thing with chlorine, that's the minus. When we do this, we need to be careful to recognize the number of ions that are created when a salt is dissolved, as well as the appropriate charge. So we just need to pay attention to detail here. Again, if we have magnesium chloride as an example, and we allow that, so that was a solid, and we're going to dissolve it, so it's going to become aqueous. Then what actually happens here is that the magnesium ions separate from the chlorine ions, and we recognize, instead of putting the 2 down here that would suggest that they're a part of a formula unit or a molecule, we put the 2 out here now to represent that that's the number of distinct particles of chlorine ions that exist in this solution. So for every 1 magnesium chloride that we produce, we get 1 magnesium ion and 2 chlorine ions. One more time, if we have something bigger, like say aluminum nitrate, which was a solid, and we want to show it dissolving in a liquid. Here we see that we produce 1 aluminum ion with a charge of 3 plus, and that ion is now aqueous. And we produce 3 nitrate ions with a charge of -1, and those ions are now aqueous. So that is how we show a dissociation reaction, or a salt dissociating in a liquid, and that's what we mean by going into solution.